All right, so chapter 7, we're going to go over a lot with rational expressions. So this is where our knowledge of factoring is really going to come into play, and I'll be able to tell who has a strong grasp on that. So a ratio of two polynomial expressions is called a rational expression. So a rational expression, and in this particular section, we're going to be multiplying and dividing. So operations with rational numbers and rational expressions are similar to operations with real numbers. Just like with reducing fractions, to simplify a rational expression, you divide the numerator and denominator by the greatest common factor. But sometimes you need to factor the numerator and denominator first before you can simplify when you're multiplying or dividing. So we're going to start basic. It says, example 1, simplify each rational expression. Under what conditions is the expression undefined? So when something is undefined, that means that the denominator would be equal to 0. So you're looking for when the denominator equals 0. Okay? So first thing you want to do is make sure everything is completely factored. So the numerator is done for us. We're good. Can't break any of that down further. The denominator, the y, is fine, but this trinomial, you need to factor. So we are looking for two numbers that multiply to get -6 and add to get a -1. That would be a -3 and a +2. And that is what that expression would look like, completely factored. So now what you do with, you cancel 1 for 1. So we have a y on top, y on the bottom, they're gone. Y minus 3, gone. And then nothing else cancels. So simplified, this would be 4 parentheses y plus 4 over y plus 2. Where this would be undefined is if you look at the factored version of what we had here, we have 3 things in our denominator. 1, 2, and 3. And what you are doing is you are looking for where they would equal 0. So you set each one equal to 0 and solve. So the first one we get y equals 0. Second one we get y equals 3. And the third one we get y equals -2. So those are the 3 instances where this function would be undefined. All right, let's try another one. So numerator over here, not factored. I got to take out a z with an x minus 4 left over. Denominator, I've got 2 z's, so I'm going to actually write them separate. And then if I notice, I have a 4 minus x. Well, I have an x minus 4 on the top. They're similar, but they're not exactly the same. So to get them the same, I'm going to actually take out a -1, which flips the order of the denominator. Okay, which now allows 1z and 1z, an x minus 4 and x minus 4. Everything is gone in the top, so that's 1. And I have a -z in the denominator. Now looking back, where this would be undefined, I've got z's, so if I set those equal to 0, I get 0. And I have x minus 4, which means x would be equal to 4. So those are your instances where this function would be undefined. So now that was simple. That was one term over one term. Now we're going to start to add some operations here. So when we're multiplying, we multiply the numerators and we multiply the denominators. So if we have a over b times c over d, for a basic fraction, you would get ac over bd. But what you're going to find is you don't actually want to multiply this stuff out because you have to factor it in the end, and it's a lot harder to do that when you make the numbers so big. So when you look at 8x, if I rewrite it right here, 8x over 21y to the third times 7y to the second over 16x to the third. So one way of looking at it would be to completely break it down into primes. So 8 is made up of 3 2's. Oops. So 3 2's and an x. Since I'm multiplying, I go straight across. 7y squared is a 7 and 2 y's. 21 is 3 times 7 and 3 y's. And then 16 is 4 2's and 3 x's. So this is one way you can do it. But you can certainly just look and start canceling. So I have 3 2's go away. The 7 goes away. I have an x that goes away. And I have 2 y's that go away. So I have nothing left on the top. But on the bottom, I have these items. So I have a 1 on the top. I have a 3 times 2, which is 6. I've got 2 x's and a y. Okay, so you can list out the primes, or what you could have done from the start. As long as it's in the top and bottom, they can cancel. So 8 and 16 make 1 over 2. 7 and 21 make 1 over 3. In terms of the variables, x over x to the third is 1 over x squared. Y squared and y cubed is 1 over y. And what you'll find is you have all 1's on the top, and then you have 3, y, 2, and x squared on the bottom, which does match with the answer that we just came up with over here. So that's your call in terms of how you want to simplify. All right. When we divide, you can't actually divide a fraction, so you have to multiply by the reciprocal. So the first one stays, and then you multiply and flip the second fraction. So it's actually AD over BC. So some people learn it. You keep the first fraction, you change the sign, and you flip the second fraction. So keep, change, flip. So with example 3, simplify the expression. So what I'm going to do, first I'm going to write it in the right format. So the first fraction stays the same. Then I'm multiplying and I'm flipping the second fraction. And whether you're one who choosing to write it out the primes, or I'm going to cancel this one. So 10 over 5 is 2 over 1. M over m to the 5th is 1 over m to the 4th. 6 over 3 is 2 over 1. C squareds are gone. D squared over d is d to the 1st over 1. And then nothing happens with the k's. So I have 4k squared, 2, and a d left in the numerator. So that's 4dk squared. And then I have an m to the 4th left in the denominator. And there's your final answer. And the thing is, if you forget to simplify something, look at your final answer and see, can you actually simplify one step further? And then you just do it. Doesn't matter if you have an extra step to go. The point is, it's completely simplified in the end. All right, so now where the factoring comes in. You have all these polynomials. So you have to be able to factor each and every one of these. So if it takes getting extra practice on factoring, I would definitely look into that if you're struggling. So 8x minus 20. So this is a multiplying, so nothing's shifting, but I have to factor everything. So 8x minus 20, I can use GCF and pull out a 4, which leaves me with 2x minus 5 left over. Second numerator is a trinomial. What multiplies to get 10 and adds to get 1. Multiplies to get 10 and adds to get negative 7. That's negative 2 and negative 5. So x minus 2, x minus 5. First denominator, what multiplies to get negative 35 and adds to get a positive 2. That's x plus 7, x minus 5. And then our second denominator, first I notice they have a 4 in common, so I'm going to take that out. And then I also notice this is a difference of squares scenario. So you have to make sure that these problems are completely FOILed out or factored out, because if they're not, you're not going to see what has to cancel out. So now that was the hardest part. So now we simplify. 4, gone. X minus 2 gone. X minus 5 gone. And we're left with the 2x minus 5 in the numerator, and an x plus 7 and an x plus 2 in the denominator. And there's your final answer. But again, the hardest part is the factoring part. So please, again, if you're struggling with factoring, look for some extra practice. This is all previous material that you have learned in Algebra 1. Not last year, but in Algebra 1. But there is plenty of factoring practice out there for you to work on. All right, for B, it's division, so I have to make sure that I multiply by flipping the second fraction. So multiply to get 20 for the first numerator, add to get negative 9, that's negative 5, negative 4. Multiply to get 21, add to get 10, that's 3 and 7. Now remember, I'm flipping, so 6x plus 42, they have a 6 in common, that's my GCF, which leaves me with x plus 7. And now I'm looking for two numbers that multiply to get negative 12 and add to get a negative 1. That's x minus 4 and x plus 3. So the hard part's over. Now the canceling. X plus 7, x plus 7. X minus 4, x minus 4. and then nothing else goes away. So you have 6 times x minus 5 on the top, and then you have 2x plus 3's on the bottom. So whether you leave them separate or combine them, it does not matter. All right, last one here. This one's written vertically rather than horizontally. So what I would suggest is rewrite it, because we're so used to it being written horizontally. So divided by x squared minus 4 over 4x minus 10. And this is a division, which means I'm going to have to flip the second fraction. All right, so when you see x minus 2 squared, that means there's 2 of them. Denominator, I have a 2, and then I need to figure out 2 numbers that multiply to get 4 and add to get -5. That's -4 and -1. Flipping the second fraction, 4x minus 10, there's a 2 in common with a 2x minus 5 left over. And then x squared minus 4 is a difference of squares. X plus 2, x minus 2. So now, minus 2, the 2's cancel, but nothing else cancels, which is fine. So we have an x minus 2. Make that an x, sorry. 2x minus 5 over x minus 4, x minus 1, and then x plus 2. And then go back and say, okay, does anything else cancel? If it does, cross it out, rewrite the answer. If it doesn't, there's your final answer. But you do not need to FOIL it out. Please do not FOIL